Right, hello, welcome back to our Cisco Certified Network Associate 2025. So this will be the episode 5 of the series. So last time we've started with the switching. Now we're going to discuss routing. So as you can see on the title, so we're going to talk about what routing is and why it's important to learn, especially if you'd like to have your CCNA or even just to have a career in network. Okay, but first let's define what routing is. So by definition, it says here, the term routing is used for taking a packet from one device and sending it through the network to a different network. So as simple as let's say you have 192.168.1.0 and this one is 192.168.2.0. So routing, it's as simple as sending one packet here going to this network, because we know by default uh, if you have two networks that are not belong together, by default they're not able to connect. So what you need to do is to route them, to use a router enable for you to connect those two network. So now, why we would like to connect those two networks? If we're going to apply it in real life or real world setup, let's say you have here, let's say this is um, a router, and then you have here the internet. Let's say this router is like an office here in the Philippines, like PH, or just like right PH. So we know that there are a lot of BPO industry here. So usually there's like a building here, and then this router is connected to a switch, and that switch is connected to a multiple computer where those people working to the BPO are connected. So this network might be 192, 168, 1.0 network, and you might have a main office like in the US that has a different network, and that network might be like 10.0.0.1/16, right? So why we would like to connect, or why we would like to route those two networks, is simply as if you're working here in a real world setup, most of the time you need to have access to a certain server, like let's say this server, and this server might be 10.00.100. So this server might be a database of information for specific clients. Let's say it's like a service provider, like a telecom, like maybe AT&T, Verizon. So they do have a certain data server which they do have like the information of those clients. So in order for people here to work, they need to connect to that server, and the only way for us to connect this network going to this server, that would only be in a form of here routing. So that's the reason why we have to study routing, and that's the main purpose why we need to learn this technology. Now says here that router uses routing table to make decisions. We're going to explain that later on. Routing can be manually or dynamically configured. So for static routing, it's manually enter route information and uses simple routing algorithms and provides more security than dynamic routing. So it does not handle failures in external network well. So the first form of routing that we're going to discuss would be static routing, because it's very easy to configure. So I think this is a good way to start routing. Let's say you have here 2901. So I just pick two routers right here and then connect them with link. So let's say this one, connect this one, and then you have here like a computer. So let's say, let's follow the example that we created a while ago. Let's say you have 10.00.2, it's slash 16, so that's 255.255.0. The gateway would be 10.00.1. So actually any part or any part of that network, you can use that as a gateway. So usually we're going to use the first value of that specific network, like the first available IP. It's not always the case, but it's the best practice to use the first IP of that network as the gateway. So if you set 10.00.1 here slash 16, so if you go to the router, configure it on the CLI, what you need to do, okay, so again, enable config terminal, go to the interface, so that's interface gig 0 over 1, so IP address 10.0.0.1 255.255.0.0. Exit, if you can see it's not going up, so you need to input the no shutdown command here, and to verify if your IP address is ready in the router, you show the show IP interface brief. That will show you what IP you input from 01. So let's say this one, let's follow the one that we provided, the example. So 168.2, so that's slash 24 192.168.0.1. so go to the router for network 1, so no, then enable configure terminal, go to the interface 01, then add the IP address, so IP address 192.168.0.1 then again it's not going up, so you need to use the command no shutdown, exit, verify the IP address, show IP interface brief. So as you can see, it's already 192.168.0.1. So now in order for them to connect, so we need to have the point-to-point connection for those gig 00 and 001. Maybe we can use 172. So configure terminal, so interface gig 00, so this will be the hop. So we need to have like a network for router to router communication. So let's just say 172.168.0, and then you use slash 30, so that it will be point-to-point network. So interface IP address 172.168.1.1 255.255.248. Okay, and also no shutdown, and also go to this one, configure terminal, IP address interface 1 gigabit 000, IP address 172.168.1.255.255.255.248, and then no shutdown. So for this one, we already have the IP address configured, so we have IP for router to router. We also have IP here for router, and also for show IP interface brief for the router 00 for the router, and the main network will be 0.1. Now let's try to ping from the gateway first. So IP config to check your IP, so this is 0.2, so your gateway would be 192.168.0.1. so we're able to ping. Let's try to ping that network, so that's ping 10.00.2. so as you can see, it's not enabled by default, so the configuration that we need to do, we need to choose for any of the routing protocol, or we need to route those packets in order for them to communicate. So go to the router. The configuration is very easy. Config terminal, then all you have to do is to type IP route, and go for the destination network. Let's say the destination for this one is 10.0.0/16, and this network is 168.0. 0/24. So you know that from this router, the destination network that you need to reach would be 10.0.0.16. So that's going to be IP route 10.0.0 space, and then the subnet mask 255.255.0.0, and your next hop would be 172.168.1.2. Why 1.2? Because you know that the IP address of this router would be this one, 1.1. So the next hop should always be the facing interface of this router. So enter. And you have to do that on the other router as well. So for this one, config terminal. So from this router, the destination network would be this side, the 192.168.0. So that's the same command. IP route 192.168 0.0, network 255.255.0, and the next hop again, so this is 172.168.1.2. So the next hop would be 172.168.1.1. Okay, exit, and then let's try to ping now. Okay. Oh, okay, so here we go. I thought it's not going to work, but yeah. So now that's the simple configuration of static route. So let's try to ping 192.168.0.1, and the computer, that one. And like what I provided a while ago, this could be a server, like let's say like for example, let's try to pick any of the server here, like the one that we provide an example. If we're going to let's say this one, this is a server. Let's see the configuration, like the HTTPS, or this one, let's say the IP of the server is 10.0.0.100, 255.255.0.0, and then 10.0.0.1 the gateway. So let me ping the gateway first. Okay, so it's all good. So I'm not going to change with the configuration because I already create a route for it. But just to give you an example, let's say the services here, or like let's say this is like an HTTPS server. So if I enable this one, I know that I can reach this server. So maybe it's a web server that have like the tools needed for this company. Like let's say go to the web browser, 10.0.0.100. So as you can see, that 10.0.0.100 is this server, and that's actually a web server. And that again, that could be a specific server that might be using for like maybe handling calls, or maybe getting information, or maybe for troubleshooting customer. So that's how important routing is, because you get access to a specific network, and that network might be related to the kind of setup that this network A is doing. Okay, right, so we're done with the static routing. Next, we're going to have a quick overview of what dynamic routing is. So the problem with static routing is that if we're going to have here and here, like A and B, if you're going to check the previous configuration a while ago, you're going to see that we defined the next hop going to this network. But what if we have multiple hops here, this one, and we configure a static routing on this one to reach this server, and suddenly this link went down, right? So basically, what the problem with static routing is, since we manually configured the route going to a specific destination, so once this one is down, the only way for this network to go to this server is that someone from the IT or from the network needs to configure another uh, routing once this one is down. And not every time there's like an available engineer to check on those configuration and router to resolve the issue. And let's say that this one is a critical server, and these people will not be able to work if they don't have access to the server. So basically the whole production is going to down, and that's something that the business owner does not want to have for any corporate setup. So that's why static routing is only good for a small setup, especially if there's only one link going from network A to network B. But other than that, we might need to use dynamic routing in order for us to make sure that the redundancy and multiple paths will be utilized. Because in dynamic routing, so if you're going to use a dynamic routing in the setup, there will be path 1, path 2, and path 3. And once this one is down, depending on the routing protocol, it will choose a different path. Here, it could go to this path, or it could go on this path. So that's why we have to also know the dynamic routing protocol. And the most common routing protocol, not the most common, but the very first routing protocol, or one of the first routing protocol, is the RIP, or routing information protocol. So for this case, it uses hop count as a metric. So let's say we have two paths right here. So according to RIP, it will choose the hop count. So if you have path 1 and path 2, it will choose this path because basically it has the lower hop count value. So that's how it decide the best path. So there's also a distance vector protocol with an AD value. So we're going to talk the AD value next time, but it's good to know that AD value means the lower it is, the more reliable the route is for the router. So if it's 110, so it will follow that protocol. If it's 50, it will follow that specific path itself. Okay, so commonly used for small to medium network and uses port number 520. The port number 520 is just basically the port, like how HTTPS uses port 443 to use the communicate on the server. So it also uses specific port for its communication. So next, based on the number of hops, it also updates the routing table every 30 seconds. The problem with this one, because we don't have, or we did not talk yet with other routing routing protocol, but the problem with updating every 30 seconds is that RIP, being a very old protocol, like let's say no changes on the network for the whole day, all the networks are up, like all the links are up, so it will still continue to send 30 seconds. I mean, it will still continue to send routing updates every 30 seconds, and that's not very good for network traffic, because basically those updates every 30 seconds does not have any value on it, since there are no changes happening on the network. So that's the behavior of a distance vector. So as you can see here, it also says that how does RIP work. So we do have specific timer, like this one. We have the update timer. So the default timing for routing information being exchanged by the time operating RIP is 30 seconds. So using an update timer, the routers exchange the routing table periodically. So the configuration for RIP is very easy. So let me just configure that one here. Let's say I'm going to remove the static route. So no IP route 10.0.0, that's 0255.255.00172.168.1.2. Okay, so I just removed the static route. And for this one as well, no IP route 192.168.0.0.255.255.255.0.172.168.1.1. So if I'm going to ping that server again, I'm not going to reach it, right? So let me just show you the configuration for RIP. So this one will be very quick. Configuration is much easier. Let's go back to it. So as you can see, it's unreachable. So with RIP, if I'm going to show IP interface brief here, you'll see that the available network that I have here would be 172.168 and a 192.168.0. So if I'm going to configure terminal, the configuration would be router RIP, and we're going to use version 2, because version 1, um, it's not like it's I don't think that it's still being used because of the authentication issue, and also it's a classless routing uh, protocol. So when we say classless, so if I use a specific like if I subnet this 192.160.1, it will not read it as the subnetted network, but it will read it as the classful network. So it's, let's say you use this one and you use like 2 5 like uh 128 subnet. So that will not read it as a subnetted network, but instead that will just read it as a /24, which will might cause problem if you have those two network that's not on the same destination. That's why. Now the configuration here is very easy. So network, you advertise a 172.168.1.1, actually 1.0 if we're going to exact network, and also network 192.168.0.0. But the thing with RIP, if you're going to show running configuration, you'll see it here that it automatically updated the configuration. So this is like the class pool version of that network. So that's how RIP understands your network. Also on this one, so let's configure terminal. So router RIP version 2, then network 192.168 1.0, and also network network 10.00.0. So it again, if I'm going to show run, you're going to see that this is the classful version of that network. So that's how easy the configuration. Let's see. Oh, I'm not able to ping it. Why? Let's try to ping it from the server. Why I cannot ping? I can ping 0.2, right? How about 0.1? Why I cannot ping the network? Let's show IP route to check if RIP is working. So it's not reading our configuration. Okay, 192.168.0.0, that should read it. Why? I already removed the static route. You need to advertise this network 10.00. Oh, I forgot to advertise the 172. So sorry. Config terminal router RIP network 172.168.1.0. Even on this one. Exit. Show IP route. Okay, so here we go. It's already, there's already route RIP on our routing table. So I made a mistake on this part. I think I added the 192.168.1.0 network. You don't need to advertise a network that's not from here. So configure terminal. So router rip no network 192.168.1.0. So show running configuration. So only two networks from here. So that should be able to connect. Why? Hmm. Hmm. Seriously? Show IP route. I can reach 10.0.0 via 1.2. So why I'm not able to ping the 10.0.0.2? Ah, okay, there's no .2, that's 100. Okay, so since we changed the IP of the server, so as you can see, we're now able to to ping or connect to that server using the RIP routing protocol. Now, to go back to our timer, so it says here the update timer is every 30 seconds. So if you're going to check like this one, show IP route, you'll see, okay, this is the route like 3. If we're going to do it 11, and let's wait for 30 seconds because it says here that it always sends update every 30 seconds. Okay, as you can see, after 30 seconds it starts from 1, so that's why the interval of the time that this route is learned from here always go back to 1 second, or in just the value of 30 seconds. Now, it says here that invalid timer, if no update comes until 180 seconds, then the destination router is considered as invalid. In this scenario, the destination router mark hop count as 16. And hold down timer, this is the time for which a router waits for neighbor router to respond. The router isn't enabled to respond within a given time, then it will declare dead. It is 180 seconds by default. This is for router to respond, while this one is for the invalid route. Let's say going back to our setup. Let's say try to remove this network like the server. Let's see if we're going to see that route. Let's say show IP route. So to reach 10.0.0 network, let's say, as you can see, it passed more than 30 seconds, 41 seconds now. And if we're going to look at the timer, so it's going to be 180 seconds for us to say that this one will not be valid anymore, right? Let's wait. Okay, so it's already 1 minute and 8 seconds. So it will be about like 3 minutes before we can says that this timer will says that this one would be an invalid one. Then after that, after 180 seconds, it is the time which the entry of the route will be removed. So as you can see, it will not remove right away. So even after 3 minutes, it will wait for additional let's read the document. It will doesn't represent within the flash time. It is 160 by default. This timer starts after the route has been declared invalid, and after 60-second time will be okay. So after it was declared as invalid, so we will need to wait for another 60 seconds before it will be totally removed from the router. So let's just wait on this one. I just want to show you what will happen after 3 minutes, but maybe the other part, like the flash, we're not going to wait on this call. But you see uh, the how it behaves, and how REAP is, really old protocol, because that 3 minutes downtime, if you're going to check that, that's really a big problem, because 3 minutes and the network is already down, or that path is already down. Like let's say you have many more paths, like second and third fifth paths, so that will already cause a production issue. And we know if it's an enterprise setup, even 1 minute downtime will cost you a lot of money. And also that's the main reason why REAP is an old protocol and no longer in use. If it's used maybe for a very very old setup, or maybe the router only can use the REAP, that's why it's still used if you're going to see it in the industry side. But right now I'm not seeing any router that uses REAP, but it's a protocol that's very important, because this is where all things started. It's the very first protocol, so let's give it let's give the credit. And it's very easy to understand the REAP as well. So as you can see, after 3 minutes, it shows here that possibly down, routing via 1.2, so it does not totally remove it from the routing table, and the only time that it will remove it after the flash timer here. And I think we're all good with for today's episode. So we started with static routing, and also we've discussed the REAP routing protocol, the dynamic, and also some of the limitations that REAP has. So for no auto summarization, so before, like when we mentioned, it's a class full. So when we say class full, if you subnetted this network into /25, it can't route it to /25. The only thing that the router or REAP knows would be the /24. It's like the default class for this network. And loops and distance vector. The problem with REAP is that it also calls routing as a humor, or as a rumor, I mean, like a gossip kind of routing protocol, because the way it get the routing protocol is based from this specific network. So let's say I can reach network B, I'm going to tell you that I reach network B from this network. So let's say it will network A says, oh, okay, I can reach network B. If you can reach network B from your side, then I can reach it using one hop, right? But what happened is that if this goes down, and then it says here, I cannot reach router B, but it talks to this router, but I can reach router B by hop 1. So what will happen here, it will create, oh, okay, so I can reach router B by hop 2. So once it go back here, oh, you can reach router B by hop 2, I can reach router 3 by hop 3. So it means that it will continue the looping of these, because it does not know that the router B it came from itself. That's why it has this, what you call the split horizon and route poisoning. So this is how it handled the looping and the limitation of REAP. So split horizon, it's a technique to avoid network loops, straightforward. So let's say, okay, difference between, so poison like this one. So if the states that a route cannot be promoted out interface, if the next step of the route is located on that interface. So this is how REAP able to overcome this limitation. Like it uses split horizon, wherein you cannot advertise a network if it came from this one. So if it says it came from B, so I cannot send or I cannot receive routes from that network piece. So that's how remove all those limitations from it. We're going to discuss this further, but but I think we're all good with the configuration first, and then we're going to have a deeper understanding on how these split horizon and route poisoning works. But yep, I think we're all good for the routing for the day. Yep, thank you. I'll be back again for next week.